introduction for what I'm discussing today with you. Kind of a long introduction, I think it could be much faster, but I will do my best because I have to catch a flight anyway. So, as mentioned by Michael, we should not always focus on trying to improve all the technologies that are available to make stuff more accurate and that kind of stuff. And actually that was what I've been doing in the past 15 years. So within the faculty of mechanical engineering, our department, we mostly focused on the design of new instruments for minimally invasive techniques, adding all kinds of sensing, shape sensing for robotics and all this cool stuff that you can make publications about it. But as Jenny Dankerman yesterday pointed out very kindly, she mentioned that most of our devices are actually collecting dust on the shelves in the labs. So, okay, so that's your career then. So, why does it happen? Well, because we're not solving a problem or possibly not the main problem. And one of the main problems I will focus on today is probably this workflow and logistics. So, unmet needs, as Michael pointed out. This picture was taken last Wednesday, coincidental. It was the biggest hospital strike we have in the Netherlands. We have about 8 academic hospitals and then about 100 regional hospitals, and all those regional hospitals went on strike. Why? Obviously, always they want higher salary, but there are other reasons. It's mostly the workload of the personnel. And we're not talking about specialists. They are always the heroes, they can handle anything. No, we are talking about the nurses and the lab assistants and the OR assistants. They are struggling with many problems, and one of them is especially the administrative burden. And if you look at some numbers, you can collect those numbers everywhere and they will be slightly different, but they spend more than half of their time on registration of all kinds of stuff. And only a low percentage, they are actually dealing with the patients. And the people, they don't like it. They do their training to work with people. That's what's driving them. They don't want to deal with checking up and you know, doing all the paperwork. And actually, we are part of their problem because we, as biomedical engineers, we enjoy developing new technologies for them to use, to put in the operating room. But it's getting too much. These people are not technically trained, so they don't like working with these devices. They don't like to think about the settings and all the complexities. Just an illustration, so what has been happening over the past decades when you look at a typical hospital with 800 beds, there's an exponential increase in the number of devices that's being used, and that's actually introducing problems already for quite some time. About 12 years back already, when minimally invasive surgery was still growing, we went to a local hospital and we did a small observation study. So we looked at 30 operations and we simply counted how often there were problems with the equipment. On average, there were 2 to 3 incidents in each procedure. At the start of the procedure, very basic problems like, okay, there's an unclear malfunctioning, a clear malfunctioning, connection was wrong, it's not in the right position, but quite often also the equipment was not there. So imagine you're doing endoscopic surgery, but the monitor is not there. It's kind of a problem. Why was that the case? Of course, the operating rooms, they were just square rooms, and at that time, it's getting a bit more modern nowadays, but at that time we still had to wheel in all the equipment, and if you simply forget to do that in advance, you get this hiccup in the procedure. Now, most of the time people deal with these problems. They solve it in 2 minutes or 10 minutes, sometimes maybe in an hour. It's solved, but you create delays, you create problems for the operating team. Now, what we did at that time, we made a short checklist. Checklists are now very common. At that time, nobody used it. We made a short checklist. We asked the personnel to use the checklist before the operation, and we reduced 50% of all the problems. That's great. Nice solution, kind of boring, but it works, you know. So we went to the AIS, which is a bigger European conference about endoscopic surgery, and my colleague Neil Vlaasdom, he presented that work. But he mostly got nasty comments from the medical doctors. He said, checklist, administration, we have to hire personnel to do that, so we're not going to do that. That's what you can expect. So even though there is a problem, there's a very practical, cheap solution, it's not always adopted. Now at that time we said, well, okay, they don't want to fill in a checklist. We are a technical university, can we make an automated checklist? That must be doable. So then we started this project, what we call Nora, the digital operating room assistant. So we were very ambitious. We wanted to solve all safety problems in the OR. Of course, we didn't get that far, but we did get some nice results, and I will share some of the early developments. So one of the practical problems was, you know, the equipment in the OR. Is it there? Is it properly maintained? Do we know how to use it, etc. Imagine that in almost every hospital, the infusion pumps get lost because people hide them. They want to keep them for themselves. So at the moment that the technical department wants to do maintenance, they have to look for them. So they spend half the day to look for this infusion pump, which is somewhere hidden in a closet. Right? So knowing where the equipment is already a very important point. So what we did, we put RFID sensors to all equipment, or at least in this pilot to about 100 of them, so that we could track them throughout the OR complex. And we linked that information to the maintenance system. So we also knew, hey, this device has been maintained at that moment, so it's ready for use. You can use it safely in the OR. And we use this very simple tool, an iPad, we put it on the wall, and when everything was fine as it should be, it was green. And when it was not, it was red. It's as simple as that. Very basic technology. It's not a disruptive technology, not at all. But we are solving a problem. So, so we did a pilot study, so green, red, now there's a defect, and also when something went wrong, but was solved in the meantime, that's also very important information for the technical department, because most often when a device breaks down, there already have been multiple problems before, but if nobody tells them, they won't solve it. And it's better to solve it before it actually starts to burn and blows up and so on. So we also included the option to push a button and to give a notification when there was a malfunction. It was a pilot study. We did it for half a year in 4 ORs, and well, people were very happy about it. There was much better communication about the technology. And we were lucky at that time the entire hospital was rebuilt. They made this new OR complex with 8 operating rooms, and we integrated the system in all ORs. So it's actually there. If there's a malfunction, they push a button, they can communicate directly with technical departments. The OR manager has a direct overview of all the hospitals. So this very simple, basic technology solved a true problem in this hospital. now it's actually included in the time-out procedure. So before surgery actually starts, they look at the screen. If it's red, they don't do surgery. So it also had quite some impact. I'm pretty proud because it was actually implemented, but it's still, yeah, it's kind of a simple system, right? It's not, it doesn't solve all problems. I want to share another problem, a real problem. This is what we call the Schiphol board. Schiphol is the largest airport in the Netherlands, but you know what I mean. So this is a graphical representation of the starting and finalizing of operations. Let's zoom in. This is one typical day in the life of the Leiden University Medical Center. So what is represented here are all the operating rooms. In gray, these blocks in gray are actually the procedures that are being scheduled. And then the colored bar shows what is actually going on. So for one OR here, so this was the procedure that was scheduled. It should be finished after half an hour. But what actually happened, it took, well, what is it, 2.5 hours. And now there's a very intelligent system behind this. What it does, it simply takes the next procedure and puts it behind it. So you can imagine at the end of the day, it looks a bit like this. So it's a complete mess, right? So people don't know, personnel doesn't know what is going on in the OR. They don't know when to take a break. They introduce delays themselves because they take a break while the procedure has to start. And it's very inefficient. How do they keep track of the progression of the operating room? By manual registration. I have to apologize, this is in Dutch, but das ist niet schwer. Yeah? So manual annotation of things like order the next patient. The patient is on the holding, patient is in the OR, but then there's this big limitation. All they do is, well, procedure has started and the procedure has ended. So during the procedure, it's a complete black box. Nobody knows what is going on. And then the OR managers, the people, they look at the screen and then they say, if you ask them, do you use this information? Well, I don't get it. It's never right. I don't like the colors, stuff like that. So there is some way, some method introduced to help them, but they don't use it. It's not well designed. What they do is walk around, making phone calls, opening up operating rooms, just to check where they are in the procedure. And that's of course interfering with the procedure itself, so it's not safe. Can we help? Well, I don't know, but we're trying. What we want to do is we want to understand automatically what is happening in this operating room. So now there are many people here who have interest in machine learning and that kind of stuff, and well, that might be disruptive, so why not use that? But the basic principle is that, well, we have some information of what's going on, for instance, the instruments that are being used at a certain moment in time, and can we relate that to certain steps in the operating room, so that we can automatically keep track of the progress of the procedure and use that information to adjust the planning in real time, to communicate to the personnel where they have to be or whether they can take a break. And that's one of the main challenges now, at least for us. We need quite a lot. We need intraoperative data about these surgical events. We need some kind of surgical process model. And if we succeed, we have a context-aware OR with many possible applications, like predicting how long the procedure will take, do some performance metrics, automated reporting to reduce the workload, or even automation, robotics, and so on. Now, of course, for these different applications, we need different kinds of information. But in the end, the biggest challenges is that we need this intraoperative data, some sensors about instrument use, equipment use, video, audio, whatever. We have to define these surgical phases. So, well, we have protocols, we have to define subtasks, surgical steps, and we need some face recognition model, classification, regression, whatever. There are multiple methods that can be used. We don't know yet which is the best one. I think there's already a lot out there that we can use. Let's do a pilot study. So we did one clinical case study, and we looked at 40 video recordings of laparoscopic hysterectomies. Why a procedure like that? It's highly variable. The length of the procedure can be 2 hours, but there's quite some spread. So it's unpredictable. We want to look at the most unpredictable procedures because those are creating the main problems. Can we predict the duration of a procedure by looking at how and when they use the instruments? We did this by manual annotation of all the videos, so no smart technology in between yet. So we measured when do they use the instrument and in what phase of the procedure are they. So you get something like this, it's a binary signal, it's on and off for a certain instrument, and then over time we see the different phases of the procedure. Now, if you look, when do they use a certain instruments? Of course, for instance, the breast needle was only used in the beginning. It's used one time. But most of the instruments are used in combination throughout the procedure. So that's the machine learning challenge, to distinguish phases on the basis of minor differences between instrument use. But it's quite doable. You define lots of input features. You can select multiple classifier models, the ones you prefer, what think will perform best, and the output you are looking for is the prediction of the surgical phase. Does it work? Yes, it works pretty well. So over time, in blue you see how well we were able to predict in which phase people were, and then in red, sometimes we are off. Does it matter? It depends. If we want to use this to drive a robot to cut open the patient, yes, it matters. But if we want to have an estimation of procedure duration and we are off a minute, why not? You know. You can look at the different models. Some of them are more optimal, but actually all of them, they perform pretty well. There's more difference between phases that are difficult or easy to recognize, but the main point is that you have some automated tracking. You also can see which of the instruments are actually doing that job for us. So you can later on decide about if we have to keep track of all these different events in the OR. Well, if we focus on these events, we can already do the trick. So you don't have to put sensors on everything. Because although the approach is working, it's still challenging to implement approaches like this. Especially data acquisition. So now we use manual annotation. We also did experiments with putting RFID sensors to the instruments, video recording. But if you have to put sensors to all instruments, in a typical hospital there are about 100,000 instruments. It would be a huge investment to do so. You also have to maintain that. So that's one of the biggest challenges. Also, connectivity. I mean, you have lots of devices being used that you would like to keep track of, but it's all vendor specific, right? The producers don't allow you to plug into their devices. It's all closed up. We need formal descriptions of all these surgical procedures and phases. It's work to do. And then what are the exact needs that we have to focus on? Granularity. With what resolution do we have to know what is going on? Most important, scalability. How can we go from training a model for one particular procedure and make it work for all procedures in all operating rooms in a manner that doesn't take that much effort so that it's undoable. Now, machine learning takes time then to get the data. People are moving into deep learning, but sometimes it's only because they are a bit lazy. You know, deep learning can do the trick and works pretty accurate. But on the other hand, if in the end you have a model based on deep learning, you cannot always predict the outcome in rare cases, right? And in this case, we are looking at a high-risk environment. If we use a deep learning model to drive the robotic device, and we have some kind of rare patient with a very specific feature, the model might do more harm than solving the problem. So model validation is also a challenge for the future. And in the end, what problems, back to that, what problem are we actually trying to solve? What are the performance metrics? I was talking about scheduling, and then you have to go to think about cost. So if our goal is actually to utilize the personnel and the facilities to a maximum, it's not always the best solution from a cost perspective. So this is some data from Zhang et al. They looked into it very carefully, and they noticed that if you use your capacity of your OR capacity 100%, cost actually rise. So there's somewhere in between what would be the optimal. So once developing these kinds of solutions, you have to carefully measure what will be benefit in the end. Okay. Now, where are we going to? Scalability is what I think at this moment the biggest problem. As I mentioned, it's all vendor specific. So, if you can't beat them, then join them. So we teamed up with Philips. And Philips has an installed base across the world of all kinds of medical equipment and systems. And what they do, just for themselves, to keep an eye on the maintenance cycle of all their equipment, they can remotely plug into every device anywhere. So they know in real time, they can measure in real time when someone is pushing a button using a certain setting and so on. They don't know exactly what is going on in the operating room, but they know that the device is used and how. Hospitals don't let Philips in their operating room, only the equipment. They don't trust them. I don't know why, but they don't trust them. They do trust me. And Philips trusts me as well, at least for now. So we are starting this new project. And this is the concept we're working on. We'll work on. This is not my video, it's written from the internet, but this is basically what we are going to do. So we will put these cameras in the local hospital. We went through all the ethical and privacy approval. We got it. Now we still have to convince the personnel that they should be happy with the camera pointed at them. We will succeed as well. They trust me as well. I'm a very nice guy, as Michael pointed out. We're going to put these cameras there and then link the data we get from these cameras with the equipment used during the procedure. We will first focus on the cath labs, the catheter labs, because, that's mainly the Philips business. And after that, we will move to surgery. By doing so, we believe, we can focus on the real problems that the healthcare professionals are dealing with now. Not only the specialists, but also the other people supporting, try to reduce the workload. We approach it in a manner that is scalable. I mean, cameras and software to do event detection and the equipment with a large installed base are relatively easy to bring together. So that's what I expect for the future. Would be great fields for biomedical engineers to work in. There's many technical challenges, but then working in a serious problem. So, well, to finalize as a take-home message, so the next generation interventional assistance, what do you have to do? Well, we need technology, of course. Do we need new technology, new interventional technology? I'm not sure. Do we have to make it better? No, that's already allowed. We have to align the technology with the users and the process to end up with true efficiency, to reduce cost, and to make sure that the personnel doesn't run away from the hospitals, and thereby even further increasing the waiting times. But so actually, there was one CEO of a hospital who very recently said all hospitals say all our activities are patient-centered. You know, they have to say that. This person was the first one who dared to say, no, we are personnel-centered. I think that is a very good point, because without personnel, in the end, we cannot help the patient anymore. Okay, I'm going to stop with that, and then there's still some time for questions. Thank you.
Hi. I want to comment, maybe follow up by a question. If I was listening to your talk carefully, and you would have replaced equipment with patient, it would have worked as well. Because what you do now, what you're trying to do is you're trying to actually make an efficient process by also making sure that everything works preventative. So why don't we do prevention on the patient? You have an institution like Philips that gets the data and make sure that everything works and is not broken, because broken is when you're sick as a patient, you go to the hospital, right, and you get fixed. But making sure it works all the time is the most important thing. And that's actually the most important thing on the patient too, or in the person too. You have to make sure that she works all the time rather than you're sick. And I think you could almost replace the equipment with patient and it would still work. But why don't we not put that much effort in prevention of the patient? But we put it now, well, it's good that we put it in the equipment. But what do we have to do to make that happen? So it's a completely different question to your talk, but
no, I understand what you mean. So I think it's the level of ambition. In your visionary talk, you look at what will happen in how many years? 10, 20?
hopefully shorter.
Yeah, hopefully shorter, but I mean it's still a bit far off from well, next year. So it's very difficult to actually make concrete projects together with hospitals or get funding because it's a major step. I do agree it's an important one. In the end, you don't want them in the hospital. You want to start monitoring the patient already at home. I mean, one of the problems with scheduling is that for many procedures, people should not eat just before surgery, right? But patients, you know, all levels, ways of communication, they often arrive with food in their belly, and then you already have a scheduling problem. So definitely the patient should be included as a parameter, and those will be the next steps. But yeah, for that, data exchange is very crucial. Now we are focusing on data exchange within the OR, and then you have to move outside the OR, outside of the hospital. So it's a good point, but we're not there yet.
Maybe one question to the surgery observations. What is the reason why the surgeries took 2 times longer? So did you also check that? Because I think what you can see are the events that you actually where you are expect, okay, this is how the surgery should go, and this is something where we can detect events to predict the time of the surgery. But in my understanding, something goes wrong, and that's why the surgery goes longer or takes longer. and these are maybe events that you cannot predict.
No, that's true. So most of the variability is related to the patient itself. And you only notice that when you open up the patient. So in this hysterectomies, uterus removal, it's really a lot depending on the medical condition itself. So we won't solve the variability, but what we hope to solve is all the consequences for anything that happens next. So by keeping track automatically what progression is, we can make at least the rest of the day more predictable. We're not going to change the operation itself. That will always be Friday. That's true. Yeah.
So actually, you just have to look on the suture procedure and say, okay, we are finishing in 10 minutes.
Yeah, that's true. In the end, it's similar as Google Maps for traffic. I'm quite happy how well it works, even though there are always, traffic jams. And then when I start driving, and for 2 hours, then it says, well, you will arrive. Then it's incredible how well it actually works, while there are many traffic jams in between. And it's more important for me to know when I will arrive than to solve these traffic jams. So, thank you very much.
Professor Dobbelsteen coming here, being part of the ISC, and as a token of gratitude, we would like to present you with this.
Thanks.
Okay.
Thank you. I will give it away immediately.
We will have a short break and come back to the next session at 4.